We'll go ahead and get started. Start off, thanks for joining me here today. My name's Jerry Thompson with Kestrel Power Engineering, part of Entrust Solutions Group. I know this is a contended time meeting. I dropped off the NERC inverter-based resource subcommittee to host this today, which for those of you who haven't had experience with, it's a great place to learn about the industry and contribute. Thanks again for joining. Today we're going to be talking about actually a NERC related project, NERC SAR 2020-06, which will be the outcome of that, hopefully be mod 26-2, so your dynamics modeling for generating resources. So to start off, I would like to give you guys some perspective of where I'm coming from, my background, Kestrel's background, and Trust Solutions Group background. And Kestrel is, in general, what we call ourselves generation control experts, and we perform services for the bulk electric system. We're actually a pretty small group. There's about 12 of us in the US, a similar number in Canada. Started in the year 2000 by some engineers with Ontario Hydro, did tuning, research and development. They were actually, call it the aftermath of deregulation, how a lot of consultants got started. So basically they were the division that they were in prior to deregulation didn't exist afterwards. And so they started their own consulting company and did what they did best. And then, of course, back Q1 of 2020, we were happy to join Entrust Solutions Group, then known as EN Engineering. We've been very happy here ever since. A quick bit of info is that I just checked our project directory yesterday, and to date we have about 5,300 projects for the bulk electric system. So that's to say, even though that Kestrel is a very small group, that if you are a bulk electric system generator owner and you don't have some form of analysis documentation from us, you might actually be in the minority on that. So to give you a little bit more idea of our background here, when I started, we really did very little concerning NERC. Our core industry is excitation systems, control systems, and that speaks for itself in the way that a few major OEMs in North America, we do PSS tuning almost exclusively for, so ABB, Siemens, Emerson, also some smaller OEMs, Basler, Brush, you name it. So we have our hands in the industry just about everywhere. And then, of course, in the years after I started, the NERC standards came out. And there's a big list here of NERC standards, but I don't want to confuse anyone. We are not a compliance company. We deal with technical content. So our work regarding all of these are specific to the technical requirements of the standards. We would come out, do testing or office-based analysis. We would give you the results of that analysis. You would put that in your NERC auditing log, so that you get all your gold stamps for passing all the requirements of these standards. Those are more of our kind of go-to, I guess, off-the-shelf type things, but we just love doing technical stuff. So some more in-depth things are, specification reviews, acting as owner's engineer, performance checks after installs and whatnot. And then we're also very active in the research community. So EPRI, we've got a couple of guys who are the chairs or, heavily involved in IEEE 421.5 that creates the models that are used for excitation systems. And of course, we'll talk through my involvement with NERC here in a second as well. But again, we are very happy to be part of Entrust Solutions Group, which really is when it comes to infrastructure, communications, automation, you name it, there's an engineering service that you need, then there is a rare chance that the greater Entrust Solutions Group cannot help you out with that. So not to do too much of a sales pitch, want to keep it very much an educational webinar. Give you some quick background on myself and we'll get started. So I have bachelor's and master's degrees, both electrical engineering from WVU, Go Mountaineers, focus in power systems and control. So when I joined Kestrel in January of 2012, I fit right in there, had a great time. Like all of our new hires, did a ton of field work. So I've been to 49 states, had my hands on every type of controller, modern and legacy, dating back to the 30s. Had somewhere in the range of 500 projects of various scopes of work, so PSS tuning, all the PRC, all those scopes you saw on one of those previous pages there. So you name it, anything that makes generation, that puts out megawatts in reactive power, then I have had experience with in some sort. Nuclear, gas turbines, hydro, everything renewable, wind turbines, PV, battery energy storage, you name it. So I've been the technical, the lead developer for Kestrel's IBR analysis tools, and most relevant to what we're going to be talking today, I did have the privilege of serving as technical lead for the NERC SAR project 2206. So without further ado, we'll actually get into that content. And I kept this, this is our outline. I won't go through every bit of it. We do cover basically what the NERC SAR project is, and then the contents of the draft standard itself. Again, this is presently a draft. We'll talk about how that's, there's already been one commenting period that we actually are just wrapping up within the standard drafting team, and then it's going to go back out for comment again. But we'll look at the structure, the details of each of these, try to leave some time for some questions at the end, set a moderate pace so that we can talk through any of the devil of the detail type items that you guys have in mind. So start out by, what is NERC SAR 2020-06 and why does it exist? And quick background, the standard authorization request, that's pretty much the proposition of a NERC standard, right? And the intent behind that is to improve reliability. So usually that, might just result in a new standard. It might also result in the retirement of existing standards. But really the issue at hand is that Mod 26 and 27, they just aren't written well for inverter-based resources. If you look at the standards, it's kind of an afterthought. There is some wording in there, but it doesn't give clear guidance on what generator owners, transmission owners are intended to prove with this standard. So of course, that's a reliability issue. So 2020-06 was proposed, of course, in 2020 to better capture the details of all types of generation, not just synchronous machines, which is the primary wording that was used. But then also, what we've seen the aftermath of NERC disturbance events, Blue Cut Fire, Odessa report, all of these things is to be able to, focus on what's called large signal disturbances. So be able to capture how inverter-based resources and synchronous machines behave when there are heavy grid disturbances. And right now, at least with the proposition of Mod 26-2, that would result in the retirement of existing Mod 26-1, Mod 27-1, which are, of course, your excitation system dynamics, Mod 26, Mod 27 being your turbine governor dynamics, and their relation to inverter-based resources. And I did add this link down here. I don't expect you guys to be able to type all of that in, but if you search, Google search NERC project 2020-06, then you're going to be brought to this page that a lot of the information that I'm referencing. I wanted to put some exciting and interesting slides on here. Unfortunately, those of you that deal with compliance know that there's only so much you can excitement gathered from these pages. So I appreciate your patience and working through some of these. But before we get too far into the standard itself, have some broad overview of really what we're looking at, the core themes of the standard. Of course, as we said, the initial goal is just to suit all types of generation, better capture large signal disturbances. But there's a lot of other sub themes that were brought into that, usually by transmission planners, but also generator owners. And one of the big hitters here is just capturing more generation by the standard. And while Mod 26, 27 existing have just explicit requirements based on MVA, in transmission level, we see that that's actually being transitioned to bulk electric system definition. So we'll talk about that more. All of these we'll talk about a little bit more in following slides. Another big aspect of the landscape is instead of having two separate standards for dynamics, active power, frequency and reactive power and voltage, we're actually combining those into one single standard. So this mod 26-2 would replace both of mod 26-1, mod 27, all of the content in one package. And that is something that we struggled with as the standard drafting team, and we went back and forth, and ultimately there's just a lot of, wording, technical, kind of structure that's involved with any standard. So we thought that this would be easier to capture all the relevant points into one standard. And there's also some technical details related to IBR that make sense, inverter-based resources, that make sense to have it as a single standard. So not to say that the route we went is perfect. And of course, that's the challenge, is there's no perfect route. You're always compromising in one way or another. So this is the path that we chose. And so far, it's, as we go through, you'll see that really each of these requirements for synchronous machines, for inverter-based resources, all of the sub-requirements are independent of each other. So of course, if you have synchronous machines, you're not being asked anything specifically. If you only have synchronous machines, none of the inverter-based resources requirements apply to you. And the opposite of that is true as well. One of the comments we got early on is that a lot of generator owners didn't necessarily care to give more information. They just wanted to have clarity on what was necessary to be provided. So that's part of the structure that we see kind of as a recurring theme. Of course, more detail for synchronous machines, very specific language for inverter-based resources that wasn't in the existing standard. So it's clear what features, what components apply to this. And then another heavy hitter is including EMT modeling, so electromagnetic transient modeling for inverter-based resources. So this is a big change from the existing that was only dealing with what we call positive sequence models. So your PSSE, PSLF, that was kind of the standard fare simulation programs for transmission planners and power flow dynamics, you name it. So we'll talk through that aspect. And there's also, because of the technical nature of what we're going to be asking for, there's also a unique implementation plan behind that to merge everyone who's been complying with mod 26 and 27 existing. So we will discuss these in detail, but if you're trying to get a few concise points across, that's a good summary. So first thing we'll talk about, and surely a lot of generator owners, transmission owners are heavily concerned about applicability. And again, the previous standards really just had MVA levels. The Eastern interconnection was pretty lax, whereas now tying the definitions to I2 for synchronous machines, any unit greater than 20 MVA connected to 100 kV above, or plant, 75 MVA or above. Eastern interconnection, that's a big difference. You'll see that as you decrease the system size, the Western interconnection, the ERCOT interconnection, it's not as big of a change. It's still a fairly big change for the individual unit level, but that's going to capture a lot more generation than before. I4, of course, dealing with distributed energy resources, is that acronym DER. Mostly interchangeable with IBR with a few nuances, but capacity 75 or above, and then the way that you treat what is actually termed a bulk electric system item, a resource. So like wind turbines, inverters themselves would be included in the BES, and then any point where the net amount of energy transported being 75 MVA or greater. And then, of course, we now have applicability for transmission level connected, so static or dynamic reactive resources. So that would be your transmission level StatComs. If you have capacitor banks, reactors that are controlled through, that have a dedicated controller, that aren't just manually toggled, any type of representation that would be needed to capture that. So definitely some big changes. And you can see there are included the bulk electric system definition. That's another thing you can search on Google. Definitely what I have here is the concise version. So if you want to go through, the top portion is from mod 26-2, the draft version, of course. If you want to go through and read those individual, there's more kind of expanded wording in the document itself, but this is a quick view of it here. So from that point, we will actually get into the requirements of the standard. The first one is geared towards transmission planners and the planning authority. So now there's just more extensive information that they are required to ask for from generator owners, from transmission owners. Firstly, being model format and details, so which models you can provide. Good comparison for that is presently the NERC acceptable models list. That's something that pretty much all of us in the United States and Canada, if you're looking to see, hey, what model should I be using to represent any of your types of generation, you can reference this document. Now the transmission planner, it is required to give that. There are, and many of you probably know, there are groups, different regions that have more extensive requirements already. And so really this aspect won't change a lot because we still see a lot of different groups fall back onto like the NERC acceptable models list. But just to say that this is a standardized portion of the standard, so that as a generator owner, you could go to the transmission planner and say, hey, what models do I need to give? The level of detail that you see there, that's more specific to EMT modeling. And that's kind of a can of worms in itself, and we'll talk a little bit more about that later. But then from that point, the models themselves, the acceptance criteria regarding, performance of the models, they pass, initialization, if they work well with the grid, all of these type of things. So, and again, something that we're seeing more and more in different areas, definitely ERCOT has them now. CAISO, you see explicit requirements for things like this. And then finally, the transmittal process. So, I've seen submittal portals for things like ISO New England. That's, not necessarily that you'd have to have a portal, but just that there's structured communication kind of infrastructure for generator owners, transmission owners to communicate with the transmission planner. So it is still fairly high level requirements. And moving into requirement 2. So this is pretty analogous to what the existing mod 26-1 means for synchronous machines, synchronous units, but then also expanded a bit. So the most notable change is addition for and note in-service equipment. So this means that if you don't have any of these sub items listed below, that means obviously then there's no model for that. But definitely some big changes being excitation limiters, outer control loops, and protection systems, whereas the previous version of the standard, it was really just your core, what's required by the standard are the core aspects of voltage regulating control loop, impedance compensation, so reactive current compensation, and power system stabilizer, whereas now we're kind of broadening that. And this is, as to the intent of the SAR to capture large signal disturbances, right? Excitation limiters, that's something that if you're moved out of your normal bound of operation, these are really the first nonlinearity you're going to run into within the excitation system. Of course, the protection in there as well. And that has been a lot of a topic of debate. So that, I think it's worth touching on here just to say that, just because you have PRC 19 that says you have to coordinate things, doesn't mean that, the transmission planner has models for that. Also that, the limiters are control aspects, not relays, which are binary. So there's dynamic performance associated with that. Just because these things are coordinated by PRC 19 doesn't mean that there won't be a system disturbance. It's actually going to force you into these protection systems. So a fair amount of detail associated with the background of that. We've also introduced, the standard drafting team has introduced a couple of terms just for clarity, in which validation is a term which means, you tested something and then you take that data back to the office and then you overlay a simulation to show that the model matches that test data. So that's the term validation. Whereas verification is kind of a broader umbrella. Really, it means that you've confirmed it from some source of information, right? That it's a referenceable, each parameter value has been derived either from rating sheets, settings, you name it, just that there's a process behind it. But really, validation can serve as input to verification, right? Because those of you who do modeling know that just because there's a setting in a controller doesn't mean that that's necessarily how some of the models treat that. There may be discrepancies between the actual control system and the models because, I mean, quite honestly, models are not perfect in general. They're not meant to be, right? They're an approximation. So that's something you'll see these terms validation, verification at different points throughout the standard. And the key point behind that is that there are no new validation requirements. You don't have to test any more than what you did previously for Mod 26-1, Mod 27-1 for any of the resources. It's just your basic voltage step. That, I mean, as someone who does modeling day to day, I can say that that's definitely not best practice, but there's a difference between best practice and what NERC is requiring of you. There are definitely circumstances that you want to do much more than just, a step test, but that's not what the standard is requiring of you. And then your verification means, all these limiter models, outer control loops, protection systems, the requirement is only to verify them, right? So not asking anyone to go out there and actually run into their loss of excitation relay. That would be a very bad day for everyone, obviously. So really that's office work. That's converting the settings in a relay of the limiter into the model representation. And I can say that us with Kestrel, even to satisfy our own curiosity, we have had great success testing and validating excitation limiters. But again, that's because we feel it's best practice. At this point, that's not a proposed requirement for Mod 26-2. So it's just to talk through some of those details. Some of these, again, you'll see these repeatedly when we continue. So that's Mod 26 for the comparable analogous. R3 of Mod 26-2 is the comparable version to Mod 27-1 for synchronous machines. Again, added detail, expanded a bit. But really, there's kind of less in governor systems that really require capturing. So we did add what we termed as kind of mechanical protection systems, just more correlating with the mechanical side control. And so for that, that's 81 being over and under frequency elements. Again, no new test requirements. It's the same, really the functional requirements for turbine governors and testing is very similar to what we had before. And of course, the exclusion for units that don't respond, right? If your governor is operated in a mode that it never responds to speed deviations, then you don't have to provide a governor model for that. So, of course, a concern that many people would have with that. That one's pretty concise. And I should point out also, sorry to switch through too many slides. Now, if you look at you are getting kind of a sneak peek. What I have here is so the Mod 26-2 went out for initial comments. The standard drafting team took that back, incorporated a lot of comments. These incorporations have not been posted yet. We'll look here in a bit, and that's going to be very soon. But what I'm showing you here is actually from the revised version after the comments. So we've added some clarity to identify that even within the standard, you'll see this title here above R2. This is for a synchronous facility, and R3 is included in that. And then when you get further down into R4, this is when you start seeing requirements for inverter-based resource facilities, right? Your wind turbines, your PV solar, any of your battery storage. So we have grouped them so it's easier for folks to understand, hey, you have this type of facility, these are the requirements that you're interested in. But to get into R4, and this is, comparably speaking, Mod 26, but rewritten better language for inverter-based resources. And the same lingo applies with in-service items, right? So only aspects which are actively controlling the unit, and the representations are pretty standard fare. Your hardware control systems. I wouldn't say that the limiting and protection systems are quite as analogous to what it is for synchronous machines, just because those of you who have familiarity with these devices, the control is actually kind of embedded, right? In synchronous machines, your excitation system controls your voltage reactive power. Your turbine governor controls your frequency active power aspects, so they're decoupled to a large extent. Where it's really not that way for inverter-based resources. These are the devices themselves. They're converters. They're voltage source converters. They're programmed to deliver active and reactive power, and those kind of loops are interdependent, because really how an inverter is rated is by its output MVA, its output current, right? So sometimes you have to prioritize. You're sourcing this current from the same point. It's just that the controls have to independently treat how the power system views this current, right? Active and reactive power. So a little bit down the technical rabbit hole to talk too much about it, but just to say that a lot of these features that deal with that type of control need to be represented. Of course, something pertinent, very much so, is voltage ride through. So we know from numerous events that voltage and frequency settings set to like PRC 24 requirements, which now the industry has made it very clear. PRC 24, it's not defining a trip curve. It's saying don't trip inside, and then follow your capability outside of. So this is something that's reared its ugly head numerous times through different disturbance reports as a root cause. So these are all things that we're intending to capture with this new wording, with this specific section for inverter-based resources. And again, no new test requirements, right? It's your basic, you go out there. The issue with inverter-based resources, it's very challenging to test an individual wind turbine inverter once it's already installed. Really, the tests you're performing are for the plant controller, right? So that's really what's steering these resources. The commands for, if it's regulating voltage or whatnot, that's the plant controller is sending these commands out to the individual resources. Similar, the next slide, we'll talk about how that behaves for your active power portion as well. But that's the intent here. You do a step test on the plant controller and take that back. Really, you need manufacturer's information to all of the converter electrical controls. Anything down at the IBR unit level, right? Your wind turbine inverter. That's information that really has to come from the OEM once the plant is in service. So that's our comparable version for IBR for mod 26-1, and R5. You're probably catching the flow of how this is proceeding. R5 has to do with your positive sequence modeling, so PSSE, PSLF for frequency and active power. So your mod 27 portion for IBR. And it's very similar wording through most of that. Really, the functional aspect is just decoupling your voltage control loop of voltage, reactive power, general control loop. So that can mean, for the previous slide, that means if you're in voltage regulating mode, your voltage regulator, if it does happen to be in reactive power control mode Q or power factor control mode, that's what it pertains to. Really, this R5 is focusing on your frequency bias, right? That's a synthetic feature for inverter-based resources because they don't truly have a speed. There's no mechanical system like there is for synchronous machines. But we know from FERC Order 842 that pretty much any new site has to have frequency bias. This is a required feature for the plant or for the grid to operate coherently, is to have contribution from all its resources. So kind of similar that the existing R3, the conversion from mod 27 hasn't changed a lot. There's really not a lot of interesting aspects here. Other than, of course, your frequency ride through is kind of grouped into this, your over and under frequency elements. But no new test requirements. You do a step on your plant controller, ideally through the frequency feedback, and observe how that plant controller would behave. Of course, due to the nature of inverter-based resources, a lot of times you would need to curtail the plant to really see that well for under frequency, because when they're maxed out, they won't rise any higher. But that's kind of one of the details of the industry is used to that. That's not, dissimilar from what you see on a combustion turbine with thermal limits. So pretty cut and dry what we see for R5. And then finally, R6, and this is a very heavy hitter. Because it's a new type of modeling that has not been required in the past. Well, I wouldn't say it's a new type of modeling. EMT modeling has been around for a long time. It's just that it has very specific purpose in capturing items that aren't represented in what we call positive sequence, right? Your aggregate three-phase representation that you see in PSSE, PSLF. And really the issue behind that is inverter-based resources. They have a lot of nonlinearities to them, right? They do what they're programmed to do. It's not a synchronous machine. It behaves, purely due to the laws of physics, the design behind it. It operates as a voltage source, whereas if you look at inverter-based resources, yes, the hardware itself is a voltage source converter, but the way these behave, because the way that people get paid is active and reactive power, that's what they're programmed to behave as. So it really throws a lot of complication into things. So like negative sequence, any type of, large disturbance, single, if a fault happens on a single phase, the way that inverter-based resources behave is not kind of standardized the way that synchronous machines behave. So that's why EMT has become such an important tool, and not to mention just that the operating speeds of these converters are, can be down into the microsecond range, whereas, that's just not, it's an order of magnitude different than the concerns that we have for synchronous machines. So really a deep dive to talk about why I can definitely present for an hour on why EMT is a necessary tool moving forward in the future. But really what we want to capture here is just that, it is now a requirement. Well, we'll see there are exclusion dates for plants built before a certain time, but in the future, the standard drafting team, identified that, and this is another one of those split decisions that we, for the sake of reliability, we're moving forward with the intent that, yes, long term, this information should be captured, for new plants being built, because part of the issue is that if you don't get the EMT model from the manufacturer during the design phase before, as the plant's being built, then there's a fair likelihood that you're never going to get it because, this is very proprietary information. It deals with, code that's even, there's what's called real code models that what's programmed into this model is actually the code that's being used by the resource. So that's programmed into the converter. So really technical aspects that you have to capture early, have to capture, things like bench test. Everyone knows that if you want to go out and test a wind turbine, you're going to have a very hard time lugging gear up into the nacelle of that wind turbine. It's really just not practical to test individual units once a plant is built. So this is due to the nature of this information. It's something that has to be, an initial requirement and can't be, hey, 2 years later, can I get that EMT model? It's definitely showing in the industry presently where EMT models are required, in California, Texas, that it's a huge challenge. So I guess I'll probably beat the drum hard enough on that. But the general idea here, when you look at the structure, there are a lot of requirements. Really, the idea behind 6.1 is that you're getting the structure of the model, that this is the way the inverter was designed. This structure is going to be solid somewhat permanently. Then you're validating that structure based on tests that are performed in the lab, right? They run that resource, the wind turbine, the inverter, through a series of tests with a simulator. And then, so in that way, they're validating that model structure is solid. It's going to be suitable for, the different grid events you're going to throw at it. And then further down, you see, you're really looking for the plant aggregate model, because you're not only using the resource itself, you're also combining that with the other hardware that's in the plant, right? You're even down to the conductors that link the individual resource, your transformers, saturation of the transformers, what you can provide for what's going on around it in the grid. So there's really a translation that needs to be done. Particularly considering that, there are a lot of tunable parameters that may get changed, not only in the plant controller, but at the inverter level. There might be firmware updates that significantly change the way that these inverters or the resources behave. But the idea behind that is that the structure is solid. And then at that point, once it's commissioned, you're just updating all of this information with as left settings. So the idea being that all of these things done together will give, the highest quality our best ability to represent these this type of resource in the plant as a whole. When we talk about protection systems and things like that for EMT models, really it's not something that the layperson would have access to. A lot of these things are proprietary. You see these EMT models termed as black box models, which means that the average user doesn't have any access to what's internal to that. But that's pretty much okay for our intents and purposes, just as long as the manufacturer knows what information needs to be represented. And there is actually a list, the page that has this that we're looking at, Mod 26-2, there is a list of examples to serve as guidance. And that was another thing that the standard drafting team kind of struggled over, because everyone knows that certain, it's kind of like cars, each technology is termed different things by different OEMs, so we didn't want to be too prescriptive in the idea that if it's not captured, then people aren't going to include it. So we tried to ride that line of being understanding concepts, behaviors rather than specific terms. So again, a lot of details with that. But the good thing is that there are outs for all of these requirements. If you just can't get that information right. The other challenge with this is that you're putting the OEM a lot of requirements through. It's on the GO, but the OEM has to provide it, right? So the standard drafting team identified, we can't make requirements that a generator owner can't function, or generator transmission owner can't functionally provide this for. So just to be clear that if there's information that is simply not available, then there's provision for that. From that point, pretty cut and dry, the same validation. So test versus simulated requirements. And really that depends on the individual model. A lot of times, frequency response is kind of termed, especially from the plant controller, isn't subject of interest to, EMT modeling, just because it happens in the spans of, like a 10 plus seconds usually, or it might be shorter than that, but things like fast frequency response, really, synchronous machine emulation type behavior is something that could be captured, would be relevant to be captured, just because EMT modeling, I have an i7 computer, and running a PSCAD simulation for, 10 seconds takes about 15 minutes. So you definitely have to be judicious about how you plan to use this type of resource. So again, a line that we tried to ride and use judgment on what information is useful. And then finally, we have, really, we almost use the term benchmarking, but benchmarking has kind of an assumption behind it that they're intended to match. Really, what transmission planners came back with is useful is that comparison of identifying the failures, or the what's not represented in positive sequence models. So transmission planners knowing that in the EMT model, certain things match very well, whereas in the positive sequence model, you just don't have the level of detail required to match what's going on. Because again, models, it's beauty's in the eye of the beholder, and you're always limited by the technology that you're using. So not to say that EMT and positive sequence models should match in certain circumstances, because as we know, you really can't reproduce a single phase fault in positive sequence and expect the level of fidelity that you would get in an EMT model. So it's really having that understanding of where the shortcomings of these models are that 6.5. And I should say now there is kind of a section that's, towards the end, the attachment 1 of Mod 26. It's important to know that presently, and this is the draft version that we're working with now. Prior to comment, the date is 2020. That any plant before this, you wouldn't need to provide EMT models, but this is one of those tentative items. So it would be, again, new plants when you can actually capture this information. So spent a lot of time on this slide. So if you guys have further questions about that, then we can follow up, but I think that's probably sufficient for the overview. R7, and this one's pretty cut and dry, really just has to do with, if changes are made to the resources, that you have to update that model. That's fairly consistent with the language that's in the existing Mod 26-27 standards. You'll notice that the the items here are specific, these part 2.2, 2.3, these are all just pertaining to the models that are provided. So now it is worth noting, you update any of your protection elements, limiters, things like that, then that would trigger it. But that otherwise pretty consistent, right? If you change a setting that would result in a change in the way the model performs, then you would need to update the models. Of course, we all know that there can be things like firmware changes or whatnot that really aren't intended to change the way that something performs. So in that case, we're trying to capture that it's not just, hey, every time that you open a box, you're having to redo modeling or redo your all of your documentation associated with that. So that double-edged sword of being too specific or not generic enough. But again, the intent here is consistent with what's in mod 26-1, mod 27-1. And then we got R8 and R9, and this is really, it's in our experience not something that happens often, but it does happen. Say a generator owner, transmission owner submits their model information, the transmission planner sees an issue with it. Now they have to, this is basically the structure that manages that back and forth between the transmission planner and generator owner. So it's important to identify that, there has to be an explanation from the transmission planner of why the model isn't suitable, and provide evidence, not just an explanation, but evidence of why it's not suitable. And then the generator owner, of course, has options to update the model, kind of re-go through that process through re-verifying the model is another option. Or if they feel feel very strongly about their position and can argue that in an effective manner, then that's of course still an approach. So probably not worth digging into that too much. I think the intent is still with the existing standard, but some updated language in there. And of course, a big question is the implementation plan. I think both the applicability and implementation plan are one of those things that really catches people's attention, because that dictates, whether you have something to do or not, and when you have to do it, right? So any newly applicable facilities, so any unit that wasn't applicable before, but now is because of the change to the bulk electric system definitions for applicability, you will have 4 years total after the FERC approval date to meet these requirements. So a fairly wide window. It's known in the industry that there's a limited amount of resources to complete these, both within the owner's capacity themselves, but also consultants like us. I mean, I can tell you that we regularly book months in advance. So that's something that everyone has to get on the horse together about. It really is an industry effort. It's not an individual effort. And then the phase-in requirements. So anyone, units that have already, completed mod 26-1, mod 27-1, their normal 10-year periodicity would apply, but you at least get 2 years from the effective date. So say this, just for example, if the effective date turns out to be 2020 or 2030, and you had just done mod 26, 27 in 2020, then your effective date would be, you would have until 2032 to complete that, right? It's just because your timeline goes right at the cutoff, you're not getting swept under the rug there. You'll still have some time to account for these changes. And then finally, any new plants, it's pretty consistent with the existing standard, 365 days from commissioning for your different requirements. Again, now there are facilities that have both synchronous and inverter-based generation. So, those are things that, that you kind of group those appropriately. But generally speaking, most plants would only have to deal with R2 and R3 or R4 and R5 and R6, the synchronous or inverter-based sections. And other than that, it maintains that 10-year periodicity. So moving forward, it's the same 10-year grouping that we have now with mod 26 and 27. That's the implementation plan, and that's part of some of what I pulled from that implementation plan has been updated. If you look on the website now, the implementation plan that's shown, I don't think it's been updated to reflect some of the response to comments that we have. So again, you're getting a sneak peek of some of these details now, just because of my involvement with the standard drafting team. But you know, it's coming up soon. We dealt with a lot of these comments, tried to be as thorough as possible. We just made another pass to get really not only the items that were bandwagon items that everyone felt strongly about, but even, you know, the one-off comments. So look for that coming up. Anticipated for repost here very soon. And this is tentative. It's not. These dates aren't firm, so don't write those down with the pen. Write them down in pencil. But definitely, everyone should know that this time is when you can make a difference. I want to reiterate that the intent of this standard is to improve reliability. The standard drafting team did what we could, but you know, no one's perfect. Now is your chance to bring up any of these items that you think, hey, why does this applicability improve reliability? Now is your time to voice your opinions. And of course, there are a lot of comments existing already for many of these items, but this is how the industry grows together, is by everyone's involvement. So definitely be active as much as you can for this. And that's all I have prepared for you. So we have some time for some questions. Also to share what we have lined up for future seminars, the Power Gen services. So not sure how you guys generally take questions here, George, if it's by comment, through text, or if open up the...
Hi, Jerry. Jeanette here. We received a couple questions in the chat. Okay. The first one is the exemption for pre-2020 HVDC stations applicable to all requirements or to only R6 EMT modeling?
That's specific for EMT modeling. Yep, the 2020 date is specific to EMT modeling requirements. Yep, thank you for that.
Jeanette, did we have any other questions?
That was the only question that we received.
Okay, so at this point, I guess we can have an open forum. If anybody has any questions, please feel free to take yourself off mute and ask away.
If there's no questions, I'll just assume I did a very good job presenting. So I'll take that.
We did receive a couple in the chat. The questions are coming through privately. So the first one is, how is EMT model verification supposed to happen given limited resources and or with smaller entities? Have there been any discussion?
Yep, and that is actually something that the time frame has been adjusted for. Our first response to comments, the timeline was basically 1 year from the date of enforcement. So, right, you've got that 3 years from when Mod 26 gets approved by FERC into where you actually have to provide that information. So we tried to build in that buffer, knowing that, you know, it's going to be tight on resources for basically everyone. So that's definitely a continued point. And really, it's interesting to see the debate of transmission planners say, hey, we need this information yesterday, and generator owners, transmission owners saying, hey man, like we're doing what we can, and it is challenging to get this information. And the same with us as consultants, right? I mean, I can say for Kestrel, we're always busy just doing positive sequence modeling, and keep getting continued more requests for this. So it's definitely something we considered, and it's, I guess, one of those debate type things that I guess a good compromise is when no one's happy. But again, your ability to voice your concern through that commenting period, I would very much advise doing so. So hopefully I answered your question appropriately.
Thank you, Jerry. The next question is, if we do a hardware change out within our reporting interval period, will we need to report on change to MOD 2627-1 or to MOD 26-2?
That's a good question. I would think that's a good question to clarify with the drafting team. I would imagine that if the standard is already effective, and you know that, then you would be held to the new standard. But I can't say. I'll be honest. I focus a lot more on the technical aspects than the compliance portion. So I know that time. I expected that the testing or the phase in and all that would bring a lot of questions. I'll be honest that I'm probably not the most effective at answering those questions, but I believe the intent behind that would be that if you do change your hardware while the new standard is in its effective timeline, then you would then have the year to meet that requirement, because you're kind of resetting your compliance date when you do that hardware change, right? So I believe that's correct.
Okay, the next question is, how will entities test to verify EMT models?
Yep, good question. So the test requirements are very similar to, I mean, you can use the same data as what you do for the positive sequence modeling. And of course, the idea, what's challenging behind that is that we know that that's really only based on the plant controller, right? And that's not what EMT models are generally purposed for, right? I mean, it's a wide variety of things, but really the plant controller operates in an order of magnitude different than what the inverter level items do. So the testing is still, based on the plant controller, hopefully, and that's why we tried to leverage with the bench test from the OEM, being that all of the large signal performance, all of the things that are really most interesting for EMT modeling is going to be sourced from the OEM during those bench tests, and all of that will have been validated to a reasonable degree. And then really, if you think about it in the way that it's structured, is that what you're proving is that the plant model in aggregate is reasonably accurate, that you're able to match results from the real world with that plant aggregate model. So again, you're not going to be going out there and throwing some conductors on lines and watching a fault response. It's the same test input data as what you did for it's your voltage reference or frequency feedback step. So thank you for that question.
Thank you. The next question we have is, what if 6 MVA hydro plant shares an interconnection with an I100 MVA BR? Is this considered a single facility or facility applicability?
Man, that sounds like I'd have to put my lawyer hat on for that one, and it's a pretty shabby hat. I guess I'd have to look at the specifics more. I want to say that it would be grouped. I know I've heard of similar situations from other customers I've had to be on site testing these tiny landfill gas turbines 2 MVA because they're connected to the same point as full size. Well, I say full size. Your frame 7 FA GE gas turbine, 100 and some megawatts. So I believe that that unit would fall into the requirements for mod 26-2.
Thank you. We have 2 more questions. The first one is, thinking about proprietary model legal constraints, any thoughts on developing a library of joint agreed upon EMT models similar to positive sequence dynamic models that can be shared with the planning coordinator and transmission planner?
Yes, absolutely. And I should say that there is a lot of ongoing work on that matter. I know EPRI has put out a couple of papers about, they're generic PSCAD models, which is kind of a, kind of back and forth of how specific is it? But there are models out there that capture the general structure. And most interesting, that's for cases where you just can't get good information from your OEM. There's definitely ongoing work in that area. I know there's a lot of different firms that spend a great deal of time. And so again, I referenced that NERC inverter-based resource subcommittee. They do monthly meetings, and it's actually going on right now. But a lot of the developers of this type of information present regularly on there. So I guess to more directly answer your question, I think that is an area of ongoing research that we'll see more and more information for this, but with the caveat being that certain aspects of converter control protections, of course, we're not going to get that full fidelity, which to me is really the entire point of EMT modeling. I always think that, if your misinformation is more dangerous than not having information, but there is a balancing point for that as well. So a very good question, and I think something that we'll continue to find better answers for in the future.
Okay, the next question is, what is the verification process for EMT modeling? Can you prove all the dynamic effects of EMT modeling with a simple step test like existing MOD 26 and 27?
Nope, absolutely not. Yeah, and that's really leveraging the OEM, the structure. So 6.1, when we see the attestation from the OEM, the structure is accurate, and then the bench test where they hook these wind turbines and inverters up to a grid simulator. It's just a three-phase, basically a converter that's size larger than that, and then they blast those things with all these different circumstances, ride through faults, you name it, and that's where you get the most accurate information for ensuring that EMT model is going to serve its purpose. Again, the reality of testing these, what you can test once one of these plants is built, it's pretty limited. Actually, it's kind of cool. You look at, I think, Germany, that part of the, when they build new sites, part of the final commissioning is actually bolting a fault onto these things. And I'd have to look up the reference and confirm that, but that's just not what we do in the States. Of course, hasn't gotten to that point. We might be a few blackouts away from that, but really it's that step response test. What you're looking for is really to confirm that the plant model as a whole behaves reasonably for the inputs, given actual real life input.
Alrighty, and we received a couple more questions.
Cool.
The first one is, has there been any discussion on clarifying DER threshold? For example, a 50 MW solar and 25 MW system, is that now included in the BES definition, even if the combined facility does not go above 50 MW to get to the 75 MVA threshold for inclusion?
Yeah, that one's a little bit over my capacity to answer. I think that there's definitely merit in the understanding that, hey, only one of these resources is going to be active at a time. Therefore, the plant is effectively derated, even though the nameplate capacity of each is over what the threshold for BS definition is, that, really functionally, you're only going to see part of that at a time. Again, it's the gift and the curse of not knowing many of these heavy, in-depth compliance issues, but really not my strong point. So that is actually one of the good places to ask questions, clarification type questions when this goes up for comment. I know even myself reading through the standard after the fact, there are a few things that I see that I'm like, what exactly does that mean? And of course, that's just the nature of humanity, is when you write something and when you look at it and, the standard team as a whole, we've had moments of that. So definitely a good clarification question when this comes back up for comment. It might have been addressed to some extent because I know there more and more plants have intent to operate that way, but it's not something that I can give you a definitive answer now for. But thank you for bringing that up.
Okay, and we did get a clarification for one. Someone said they may have misunderstood. Are we expecting that dynamic models for protective relays, loss of excitation, for example, are going to be required? Do reliable dynamic models for these exist in typical software? I've never seen a dynamic model reported for these before.
Yep, absolutely. So if you look at the PSSE library, I mean, there's standard library models for pretty much everything that is listed there has a standard library model for. So really, I mean, it's not too much of an effort versus, you know, when you're all of this information is still going to exist from, you know, the settings from a PRC 19 report, something like that. It's just a parameterization effort, right? It's translating these parameters that are in the relay into the dynamic model. I'm not a heavy user of PSLF, but you know, all of these simulation platforms, they kind of grow together. So if PSSE has a good feature that PSLF doesn't, or the opposite of that is true, then you pretty quickly see that captured in with the standard library. But absolutely, everything that, you know, limiter models, protection models, there are standard library models for all of them. I don't think it's popular to express them in most regions. You know, ISO New England, it was this past year, maybe year before, recently went through and required protection models from their generator owners. So that's something that, you know, that it definitely exists, and there's proof that it's being used to a functional capacity. But it's just a different aspect. I completely agree. It's not something you normally see in the expression, but you know, from our point, it's that if all of this is captured, if this effort is done in a knowledgeable and I guess well-organized way, it's not a great deal more effort than it is just to do, you know, your existing studies to tack on this information as a dynamic model. Thank you for that.
Thank
I think we had that one a couple of times in some comments as well. So you're not the only person who had that question, for sure.
Okay, we have one last question, and we are at the top of the hour. The first, this last question says, this new version has an exciter, generator, and governor turbine modeling combined. If an exciter is upgraded, calling for new models, would it be allowable to only issue the updated model for the exciter and not turbine governor? If so, how does tracking the timeline work? Presumably, the timeline of 10 years for the turbine governor modeling would not be reset, but for the exciter generator, would be reset?
That is my understanding, yes, because these requirements, again, I'd probably confirm this with an official comment, but these requirements, that was very much a big point of, you know, that was one of my key objections starting it, because we do a ton of work of that nature. You know, we support a lot of retrofits where it's not, I'd say, a ton of exciter upgrades happen without, you know, it's pretty easy to change out the logic portion and not change anything else. So the intent is that those are independent items. R2 and R3 can be satisfied independently, and then the timelines for those are, you know, you just keep track of them within their own frame of reference there. And similar, I mean, it's kind of a similar concept for inverter-based resources. We've seen, you know, tuning changes for a voltage control loop, or enabling or reprogramming of droop and deadband on the active power frequency, the bias feature. The intent is to keep those separate, just because of the nature of the hardware, right? So, yep, good question.
And that is all we have in terms of questions. Thank you, everyone, for submitting those.
Yep. Thanks, everyone. And so shared my contact information, but definitely reach out. It's a great topic to keep our ear to the ground for. Again, it is changing. And again, we all have the impact to help it change. So a very, very exciting time that we can all help steer the industry together. So appreciate you, and stay tuned for the next one.